guys. Today we're going to learn about a matrix, what a matrix is, and what operations we can do with them. Matrices are used to do all sorts of things. Anytime you can organize data, it's very useful. In computer science, it comes up a lot. What we're going to use them for is for solving systems of equations. It turns out that you can turn systems of equations into matrices. And then once you do that, they become really easy to solve if you have a calculator or a computer. So we'll use that next class, but today we're just going to be learning about what a matrix is. So when you have more than one matrix, when it's plural, we call it matrices. So matrices or matrix. And a matrix is an n by m, that's how we read this, we say n by m, rectangular array of elements. The elements are going to be whatever is inside of the matrix with n rows and m columns. So this tells you how many rows there are going to be, and this tells you how many columns. And a row, of course, is how many horizontal things there are. A column is vertical. So this is how many rows there are and how many columns there are. So this is the way we read this is, how do we say this out loud to ourselves? How do we say these dimensions? We say 4 by 2. 4 by 2. A 4 by 2 matrix will have 4, the n is always the number of rows, so it has 4 rows. Look, 1 row, 2 rows, 3 rows, 4 rows, and 2 columns, 1, 2. Notice it is a rectangular array. We always put these brackets around it, and it's filled with elements. The elements are just the things that are inside of it. Notice, it could be numbers, it's usually numbers, but it could be like variables, imaginary numbers. A heart could go in a matrix if we really wanted to. A binomial is a single element. I plus 5, that's just one element. Notice that it lines up with each of these, even though there's 2 terms. It's still a single element. The way we name the elements is we say the row and then the column. So if this, a lot of times we'll use the letter A for a matrix. We'll say this is A. Then we say what row it is and column it is. The first number is the row. Oh, you guys can't see this? We'll say A, that tells us it's matrix A. And we'll say the row it is and the column it is. So this says it's in row 1, that's row 1, and column 2, so column 2. So this is A12, it's 2. What is A32? What is A32? And I hope we notice that it's the third row, so 1, 2, 3, this is the row, and then the column is the second column. So third row, second column is 2.7. What about A41? This will be the last one of these we do. A41, and it's the fourth row, 1, 2, 3, 4, and the first column, so E. What about A23? This says it's the second row, third column, 1, 2, 3, but there is no third column. So this would be undefined. It's not defined here. Okay? So I hope we feel good about the naming the elements. The first number tells you the row, the second number tells you the column. Okay, let's look at a new matrix, and I want you guys to tell me about this matrix. What are the dimensions of this matrix? How would we write it down? And I hope we recognize that we write it as the number of rows by the number of columns. So the number of rows, there are 2 rows by 1, 2, 3 columns. This is a 2 by 3 matrix. 2 by 3 matrix. Okay. What is if this is A, what is A31? A31. And I hope we recognize that this is saying it's the third row, 1, 2, 3, but there is no third row, so this is undefined. Okay. So that's what's going on there. If I had said A13, that would be the first row, third column, and that would be x squared plus 4x. Okay. All right, let's talk about what operations we can do with matrices. We can add and subtract matrices. You can add and subtract them just by adding and subtracting the corresponding elements. That means the ones in the same spots. So you can add A12 with B12. If it's in the first row, second column of the first matrix, you can add it with the first row, second column of the second matrix. You just add the elements that are in the same spots. Okay? If the dimensions of the matrix, that means the rows by columns, if the number of rows and the number of columns aren't the same, then the sum and difference is undefined because you'll try to be adding things that are undefined. So this first one, we have a matrix and another matrix. What are the dimensions of this matrix? This is a 2 by 2 matrix. What are the dimensions of this second matrix? Well, this is also a 2 by 2 matrix, and if they have the same dimensions, you are able to add them. So let's look at how it works. Well, we're going to add A11 with, if this is matrix A and this is matrix B, we'll add the corresponding elements. A11 plus B11, the first thing in the first row, first column plus the first row, first column, and that's 10. Then we'll add the first row, second column with the first row, second column. This is A12 plus B12. So what is the element that will go here? Well, you're going to add -5 plus 4, and that's -1. How about this is going to be A21 plus B21, the second row, first column. What is the answer in the second row, first column going to be? Well, I hope we see that this is going to be 3x plus 7x, which is 10x. And finally, we've got the second row, second column, second row, second column, and we can add these together. Now, you can only combine things that are like terms. X squared doesn't add with anything, so we're still going to follow our algebra rules. X squared doesn't add anything. 5x plus 3x is 8x, and 2 doesn't combine with anything. So this is all one element. X squared plus 8x plus 2 is all the second row, second column of this, and we got that by adding this row and this column. So hopefully we feel good about adding and subtracting matrices. Okay, you can divide and multiply a matrix by a scalar. A scalar is just a number, or it could be a variable, but it's not a matrix that is outside of the matrix. And it works exactly like you would expect it to work. You just multiply each element inside the matrix by the scalar. It's kind of like distributing, right? So 3 will multiply times each element here, and so the first element will be 3 times 1, 3. What will the second element be? Well, 3 times 2 is 6. The third element will be 3 times 3 is 9, and the fourth element will be 12. So that's multiplying by a scalar. PEMDAS still applies. If you have a matrix that's being subtracted with a scalar times another matrix, you will multiply before subtracting that matrix, and you will need to respect any parentheses that exist. So what are we going to do first here? Well, we're going to multiply by 3. So I'm going to leave this first one alone. And when we multiply by 3, 3 will multiply times each of these. 3 times 4 is 12. The next one is 3 times 3 is 9. 3 times 2 is 6. 3 times 3 is 3 times 1 is 3. And now we have 2 matrices that we can subtract. And the question is, do they have the same dimensions? What are the dimensions of this first one? This is 2 by 2. The dimensions of the second one are also 2 by 2. And so we can subtract the corresponding elements. What will be, if this is matrix A, if that's our answer, what will be A11? So I'm going to ask you like this. This is A11, A12, A21, and A22. What is A11? And A11 is 1 minus 12. You subtract corresponding elements. 1 minus 12 is -11. What is A12? 2 minus 9 is -7. We just subtract corresponding elements. A21 is going to equal 3 minus 6. We subtract the corresponding elements. 3 minus 6 is -3. And A22, 4 minus 3 is 1. So that is our resultant matrix. Now, guys, subtracting, multiplying by a scalar, those all come up sometimes, but the most important operation by far, we're going to spend most of our lesson on just one operation because it is the most important thing. It's the operation you end up doing the most often. It's the thing that actually is the most helpful. It's matrix multiplication. And matrix multiplication is not as intuitive. It's not exactly how you would guess it would work. You can multiply 2 matrices together if the number of columns in the left matrix is equal to the number of rows in the right matrix. So if you have 2 matrices multiplying together, you need the number of columns in this one to equal the number of rows. And it's really easy to do if you just write out the dimensions. So if you write out the dimensions of matrix A, so rows by columns, and you write out the dimensions of the right matrix, rows by columns, then what you're looking for is the number of columns and the number of rows to be equal to each other. We want B to equal B. And so if you just put the dimensions right next to each other, it's like, are the two things next to each other? Are they the same? The two center ones need to be the same as each other. That's pretty easy to remember. And the dimensions of the product, once you multiply them, the answer will have the leftover dimensions. It'll have dimensions of A by C. So if they don't have the same number of rows and columns, if this one isn't equal to each other, the product is undefined, okay? So let's look how this works. I'll explain in just a second. It's gonna be a little tricky. You multiply each row on the left matrix by each column on the right matrix. And so let's look, what are the dimensions of this left matrix? What are the dimensions? Hopefully we recognize this is 2 rows by 3 columns. We always do rows by columns. So 2 rows by 3 columns, 2 by 3. What are the dimensions of the right matrix? This is 3 by 2. And so the first question is, can we multiply them? And the answer is yes. You can multiply them because the 2 middle dimensions are equal to each other. 3 and 3 are there. And I know that the answer is going to be the leftover dimensions. The leftover dimensions are 2 by 2. So 2 by 2 is the leftover dimensions, okay? Now, how do we do it? Well, I'm gonna call this in matrix A, and so it's gonna have A11, A12, it's 2 by 2, A21, A22. And I am going to calculate each one. So A11 is going to be the first row by the first column, okay? So you're going to take the first row of this first matrix and multiply it by the first column of the second matrix. So the row is going to multiply by the column. And the way it's going to work is you're going to do corresponding elements of the row times the column. So the first element is going to multiply by the first element. So it's going to be 1 times 1. And you're going to add that together with the second element times the second element. 2 times 2. And then we're going to do the third element times the third element. 3 times 3. So this is 1 plus 4 plus 9. That's what's going to go in A11. So A11 is going to be 1 plus 4 plus 9. That's 5 plus 9 is 14. So again, we multiply to get the first row, first column. We multiply the first row times the first column. To get A12, the first row, second column, we're going to multiply the first row times the second column, okay? And again, we're going to multiply the corresponding elements. The first number in the row times the first number in the column. So it's going to be 1 times 0. 1 times 0. Then what's the next thing we're going to multiply? We're going to add in the second thing in the row times the second thing in the column. 2 times 1. And the last thing we're going to add in is going to be 3 times -1. The third thing in the row times the third thing in the column. 3 times -1. And so this is 0 plus 2 minus 3. 3 times -1 is -3. 2 minus 0 plus 2 is 2. 2 minus 3 is -1. That's the first row, second column. And we got that. So first row, second column. And we got that by multiplying together the first row with the second column. Now, to do the second row, first column, we're going to multiply the second row. So to get this one, the second row, first column is going to be the second row times the first column. Second row, first column. What is this going to equal? What number will this equal? And hopefully we see it's the first times the first, so 4 times 1, plus the second times the second, 5. Oh, this pen is dying. That's so sad. 5 times 2, and the third times the third. So 6 times 3. And we can simplify this. This is 4 plus 10 plus 18, and that adds up to be 14 plus 18 is 32. So that is the number this is equal to, 32. So A21 is 32. Why don't you try to find A22 on your own. So A22, how will it work? Try to predict and try to get it right on your own. Well, this is the second row, second column. So we're going to multiply the second row times the second column. 4 times 0. And guys, I don't actually write out all this stuff every time. What I do is I do 4 times 0 is 0. 5 times 1 is 5. 6 times negative 1 is negative 6. 0 plus 5 minus 6 is negative 1. And that's matrix multiplication. So, guys, let's try another one of these. It's worthwhile trying more than one of these so we can get the hang of what's going on here. All right, I'll have 2 for you guys to try on your own here. Let's do 1, 2, 3, 4 times 1, 2, 3, 4. Try to multiply these on your own. What is A1? Oh, so first of all, I guess the question is, can we multiply these? Can we multiply these at all? Well, we have to look at the dimensions. This is a 2 by 2 matrix. What's the dimension of the second one? So this 2 by 2 also, 2 rows, 2 columns. Can we multiply them? Yes, because the middle ones line up. And so the leftover dimensions is going to be the answer. So it's 2 by 2 is the leftover. So 2 by 2. Now, so we're going to get 2 by 2. So we'll have A11, A12, A21, A22. Those are going to be the elements in it. So what are all of these equal to? All right, and if you had trouble with it, let's look at how it works. The first element is going to be the first row times the first column. First row, first column. So, and the way we multiply it is the first element of the row times the first element of the column. 1 times 1 plus the second element times the second element. 2 times 3 is 6. 1 plus 6 is 7. Okay? To get this first row, second column, we do the first row times the second column. This tells you what rows and columns to multiply by. You multiply the first row by the second column. First row, second column. And it lines up with what space it's in, right? The first row times the second column goes here. So I'm just going to try it like without even writing it down. 1 times 2 is 2. 2 times 4 is 8. That's 2 plus 8 is 10. You don't have to write it down. To get the second row first column, we're going to multiply the second row times the first column. So 3 plus 12 is 15. So we multiply the first element and the second elements together. 1 times 3, 4 times 3. 3 plus 12. Last, we need to do the second row times the second column. So second row, second column. 3 times 2 is 6. 4 times 4 is 16. 6 plus 16 is 22. So hopefully we feel okay about that. Try this next one on your own as well. What is 101? So that wasn't clean. Let me write it more neatly. 101, 2, 1, 3 times 1, 2, 3, 4, 5, 6. Multiply these two together. And I hope you noticed that this is undefined. The dimensions of this, how many rows it has, is 2. It's got 3 columns. This one has 2 rows by 3 columns. And the middle dimension is not equal to each other. 3 does not equal 2, and so this cannot be multiplied. And it makes sense, right? If you try to multiply the first row by the first column, you'll get like 1 times 1, 0 times 4, plus 1 times, there's not a third element here. And so that's why this is undefined, because you would need these numbers to match up. If this had been 3, then you would have the right number of elements to multiply by, and it would work out. Now notice, if you were adding these, you could add them because you would just add the corresponding elements. And if you were adding these, this would be undefined because there wouldn't be corresponding elements. Multiplying and adding work very differently from each other. you do not just multiply the corresponding elements, you have to multiply row by column. And that actually like is the thing that makes everything work out. So that's it for multiplying. I guess I'll tell you a couple more things. We got a little bit of time here. So some other important things about matrices is there's a special matrix called the identity matrix. The identity matrix. And the identity matrix is any matrix that is called a square matrix. So square matrix has the rows equal the columns. The number of rows are the same as the number of columns. So for instance, a 3 by 3 matrix is square because the number of rows is equal to the number of columns. A 5 by 5 matrix would also be square. And it's a square matrix that has ones along the main diagonal and zeros everywhere else. So this is the 3 by 3 identity matrix. If we were going to make a 5 by 5 identity matrix, so 5 rows, 5 columns, it'll have a 1 at the top left, and then it goes along the diagonal like this. Every time you go down by a row, the 1 moves over to the right one more. So this is the 5 by 5 identity matrix. It's called the, I guess I should have written this out. This is the identity matrix. Identity matrix. And the reason it's the identity matrix is if you multiply it times any matrix you can multiply by, like, I don't know, I'll multiply it by, what dimension would, how many rows would a thing I'm multiplying it have to have? Well, it has to have the same number as this column. It has to have 3. So it'd have to be 3 by, and it doesn't actually matter what this is. I'll do a 3 by 2. So 1, 2, 3, 4, 5, 6. And there's something cool about multiplying by the identity matrix. Go ahead and multiply this yourself. So this is A, the leftover dimensions. So these are equal to each other. The leftover dimensions will be 3 by 2. And so we're going to get A11, A12, A21, A22, A31, A32. And so what are all of these? Well, I hope you saw that when you multiply the first row times the first column, you get 1 times 1, and then 0 plus 0, because 0 times 3 is 0, 0 times 5 is 0. And so you get 1. Something cool is going to happen here. Then 1 times this one, right? The 1 will multiply here, and then this will be 0, 0. So 1 times 2 is 2, plus 0 is just 2. In the second row times the second column, you'll get 0 plus 3 plus 0. So it's the second row times the first column. So 0 plus 3 plus 0 is 3. Then second row, second column is going to be 0 plus 4 plus 0. I'm just multiplying them together. 6 times 0, 4 times 1, 2 times 0. And that's 4. Last row times first column. So 0 plus 1. So 1 times 0, 3 times 0, 5 times 1 is 5. And last row, last column, 0 plus 0 plus 6 is 6. And you might notice that the answer is exactly what we started out with. Whenever you multiply the identity matrix times a matrix that can be multiplied, you get back that original matrix. And if you multiply a matrix times the identity matrix, so you can multiply in either direction, you will always get back the original matrix. So that's something cool that is about the identity matrix, is that you can multiply it by itself and you will get back the exact same matrix. The last thing we're going to talk about is there is the existence of an inverse matrix. We talked about multiplying matrices, but we didn't talk about dividing matrices. If you multiply two matrices and one of them is the inverse of the first one, so if you multiply a matrix by its inverse, the way we write it is, this is A inverse. So if you multiply a matrix by its inverse, you will always get the identity matrix. And we'll talk more, we're not going to get into in this class today how to find the inverse of a matrix, But if you multiply by the inverse of a matrix, you'll get the identity matrix. And so there's a way to check if it's an inverse by multiplying it out and seeing, did you get the identity matrix? So if I wanted to know if two matrices were inverses, I would multiply them and see, did I get the identity matrix? That's all for today, guys. We will use these matrices next class to solve systems of equations. It's actually gonna be super cool and super easy. It's gonna make it so that we can speed up. I mean, if you guys did the last homework, you saw how long some of those systems of equations take to solve. And this can make it go like automatically if you have access to a calculator. If you don't have access to a calculator, you wanna solve it the way we did last class. But if you have access to a calculator, matrices are gonna be super easy. There's this whole like matrix button here that you can play around with. And if you go here, you can like mess around with the matrices and put in matrices. So it's pretty neat. You can edit your own matrices and make them. And we'll be using this to solve systems of equations. We'll talk about that next class. I hope you have guys, solving systems of equations is just one thing we use matrices for. As we get to advanced math, there's a ton of other things we could use them for, but that's all we're gonna do it for in this class. I hope you have a great rest of your day.